So if you're looking at self-sufficiency um, in this space, which is electric, autonomous, and connected, um, electric definitely. The good thing about an electric vehicle is it will have fewer components as compared to today's internal combustion engine based vehicle. Uh, but some of these components will be carried over from the current technology. Some will be totally new, and a few will be dropped. In the sense, what you see in your vehicle today may not be there. So when you talk about building the ecosystem, it's a combination of all these three. What you can take forward, what you need to drop, and what you need to create new. So let's start with the new part, which is typically the lithium-ion batteries and also the electric motors and all the electronics that comes along with a vehicle like this. And also there is a need for lightweighting the vehicle itself. So these are some of the things that would come in as new. Few things that would continue in a sense, not a big disruption, but there will be evolution, but it will still continue. Would be the seats, suspensions, tires, those kind of technologies. Even the electric car would need all this. So it's going to have a continuous evolution rather than any disruption in that sense. Of course, a lot of the moving components and the components related to the engines and powertrain will undergo a fundamental transformation. And so you won't see many of them in this new vehicle. And so those are the ones where we need to look at the suppliers who are traditionally been supplying these components, how they can reinvent themselves and get into the newer technologies. So primary focus would definitely be on the batteries itself and lithium-ion batteries, right from cell manufacturing to overall assembling a lithium-ion battery pack. And then, of course, the electric motors. From a self-sufficiency perspective, one of the bottlenecks could be the materials that goes into the construction of these two important subsystems. For example, if you look at the lithium-ion battery, we are looking at materials like lithium, cobalt, which are key materials for the electrodes of these batteries. And these materials are not uniformly distributed across the globe. They are concentrated in certain geographic regions. So one of the early technology problems that we need to address is how to mitigate the risks around the availability of these critical materials like lithium and cobalt. And when you look at the motors, again, we need very strong magnets if you are looking at making compact motors. And this is where the rare earth materials would come in. And just like lithium and cobalt, the rare earths are also concentrated in a few regions in the world. So we need to look at either alternative technologies or ways in which we can mitigate the risk around the availability of the rare earth materials also. So from an Atmanirbhar or a self-sufficiency perspective, I would say that we need to identify some of the materials bottlenecks and start developing alternative technologies or approaches to systematically mitigate the risk around availability of critical materials. Otherwise, I'm quite confident that we'll be able to develop either the battery technology or the electric motor technology, or all the associated electronics, everything in-house. I think we have a fairly good knowledge base and a network of experts across who can do it indigenously. So I'm quite confident about it.